Hi, this is Priyanka Tiwari with another topic of NCERT Maths of 9th Standard. Students, today we are going to take chapter 15, Probability. Yes, probability is the branch of mathematics and we will see its application in statistics, economics, industries, science and technology. The well-known French mathematician of 17th century, yes, namely Blaise Pascal and Pierre de Fermat, became interested in solving the problems on games of chance and thus developed the theory of probability. Some points here are to remember. Possibility is not another word for probability. Yes, the theory of probability attempts to analyze mathematically. The theory of probability attempts to analyze mathematically the possible outcomes of happening whose actual result cannot be predicted with certainty. Now student, we will see the experimental approach of probability. Now student, the first example of an experimental approach is tossing a coin. The next example is playing with the playing cards. The next example is throwing a die. Now student, experimental or empirical probability of an event. Let's come to the explanation of formula. Yes, let n be the total number of trials for some event E. Here E is any event. Yes, denote the empirical probability of an event E by PE. We are always denoting the empirical probability of any event E by P. In bracket we are writing E. It means that probability of any event E, which is equal to number of trials in which the event happened divided by total number of trials, which can be represented by small r. Small r is the number of trials in which the event occurred and n is the total number of trials. So, probability of any event E is equal to r by n. Now student, these are the most important point which you have to remember. We are using the word probability, yes, instead of empirical probability. We are we are not saying empirical probability, just we are using the word directly probability. Yes. Now the next point is that the probability of any event is always lies between 0 and 1. It means that probability can never be negative. Yes, and it should not be more than 1. Yes, so for any event E, the probability is always greater than or equal to 0 or less than or equal to 1. Yes, and the next point is sum of the probabilities of all the possible event for an experiment is 1. Yes, and the next important point is the probability of an impossible event is always 0. Yes, the event which is not possible, the probability is always 0. And the probability of a certain event is 1. Certain means sure event. Yes, if you are sure about any event, for example, sun rises from east. Yes, so the probability of rising a sun from east is always 1. It is a sure and a certain event. Now student, we will come to the example. A coin is tossed 100 times, in which 55 times heads comes up and 45 times tails comes up. Find the probability for each event. Yes, so we will move to the solution part. The coin is tossed 100 times. Yes, that is given that the coin is tossed 100 times. So we have written the coin is tossed 100 times. It means that the total number of trials which we are representing by small n is equal to 100. Now, let the event of getting head is equal to E1. It means that E1 is the event of occurring head. Now, the event of getting tail is equal to E2. Okay, the number of getting head is R1, which is equal to 55, and the number of getting tail is equal to R2, which is equal to 45. This all necessary information is given in above example. Now, we will find out the probability of event E1 and the probability of event E2. So, P probability of an event getting head is always equal to R1 upon N, which is equal to 55 by 100. So, when we divide 55 by 100, it is equal to 0.55. Again, we will move to the probability of getting tail, which is equal to R2 upon N, which is equal to 45 by 100, which is equal to 0.45. So, when we sum up the probability of event E1 and E2, we will get 1. Here, E1 plus E2 are the only two possible events, because when we are tossing the coin, only two possibilities are there. Either head came or tail came. So, the probability of all possible outcomes in this experiment is always 1. Now student, we will take one more example. Two coins are tossed 1000 times, in which one heads occurred 505 times, two heads occurred 240 times, and no head occurred 255 times. Here no head means on both the coins we are getting tail. Yes, find the probability of an event. So first of all, we will write all the given things, whatever the information we are getting from that example. Yes, two coins are tossed simultaneously. Yes, that is 1000 times. It means that the total number of trials, which is equal to n, is equal to 1000. Now here E1 is equal to an event of getting one head, E2 is an event of getting two head, E0 is an event of getting no head. Yes, also the same thing, R1 is the number of getting one head, R2 is equal to number of getting two heads, and R0 is the number of getting no heads. So here we have, in the symbolic representation, we have written R1 is equal to 505, R2 is equal to 240, R0 is equal to 255, and N is equal to 1000. Okay, now we will come to find out the probability of that particular event. Okay, so now PE1 is the probability of an event of getting one head. So which is equal to R1 upon N, which is equal to 505 divided by 1000, which is equal to 0.505. Yes, now come to PE2, that is the probability of an event of getting two heads, which is equal to R2 upon N, which is equal to 240 divided by 1000, which is equal to 0.240. Similarly, we will come to the probability of an event of getting no head, which is equal to R0 upon N, which is equal to 255 divided by 1000, which is equal to 0.255. Yes, here one thing is to be noted down, that the probability of an event of getting one head, of getting two head, and of getting no head, when we are adding up, we will get 1. Now student, we will move to one more example. A die is thrown 100 times with the frequencies of the outcomes 1, 2, 3, 4, 5 and 6 as given in the table. Find the probability of each event. Yes, the data is given in the form of table. So outcome, yes, we are getting 1, 2, 3, 4, 5, 6, and the frequency is the number of times. Yes, 1 came 18 times, 2 came 15 times, 3 came 10 times, 4 came 17 times, 5 came 19 times, 6 came 21 times. Yes, so we have added the frequency, which was 100. So now let's move to the solution part. Yes, let EI, yes, it is an event of getting 1, 2, 3, 4, 5 or 6. So EI denote the event of the outcomes, and there are total 6 possible outcomes. Yes, either we will get 1, either we will get 2, 3, 4, 5 or 6. Okay. So now we will apply the formula. So probability of getting outcomes, yes, PEI. Why we are denoting EI? Yes, it means that we are getting 1, 2, 3, 4, 5, 6. So that is a general form, which is equal to frequency of I. I is also particular, either 1, 2, 3, 4. Yes, divided by total number of times the die is thrown. Yes. So we can denote it by Ri upon N, where Ri is the frequency of I. Yes, again I am saying I can be 1, 2, 3, 4, 5 or 6, and N is equal to total number of times the die is thrown. Yes, thus for each E1, yes, E1, which is equal to, here we are denoting EI, for EI, that is the probability of an event EI is always equal to R1 upon N. Yes, now PE1. Now instead of I, we are putting 1, 2, 3, 4, 5 or 6, and we are finding out the probability of each possible outcomes. So PE1 is equal to R1 upon N. So here 1 came 18 times. So it will be 18 upon 100, which is equal to 0.18. Okay. Now PE2. Yes, the possibility of 2. Yes, so R2 upon N. So here 2 came 15 times. So 15 divided by 100, which is equal to 0.15. Okay, now we will come to P3. Yes, so PE3 is equal to R3 upon N, which is equal to 10 by 100, which is equal to 0.10. Yes, again for E4 similarly we will find out that the 4 came 17 times. So it will be 17 by 100. 5 came 19 times, so it will be 19 by 100. 6 came 21 times, so it will be 21 by 100. So in this way we have finded out the probability of getting 1, 2, 3, 4, 5 and 6. Yes. Now when we will sum up all the probabilities of an event E1, E2, E3, E4, E5, we will get 1. Okay, now students, we will take one more example. An insurance company selected 1000 drivers at random from a particular city to find relationship between age and accidents. A data is given in the following table. So our table is provided. So the first column shows the age of driver in year. So 18 to 29 years, 30 to 50 years and above 50. Okay, and the number of accident in a year. So it may be 0 accident column, 1 accident column, 2 accident column, 3 accident column and more than 3 accident column, and the last column is of total. So between 18 to 29 age group, we will see 0 accident is 220, 1 accident in a year is 80, 2 accident in a year is a 55, 3 accident in a year is 30 and more than 3 is 70. So when we add up, we will get 402. So in this way, all the information has been provided to us. Now find the probability of the following events. Yes, so a question is that being in 18 to 29 years of age group and having exactly 3 accidents in a year. So that is the question for the age group between 18 to 29 years. So we will just concentrate over on the table part between 18 to 29 age group. Yes, so exactly 3 accidents. So exactly 3 accidents, there are 30 accidents. So number of drivers in 18 to 29 and having exactly 3 accidents is 30. We will see from the table also it is given 30. So let this event be denoted by A. If we are denoting this particular event by A, therefore the probability of that particular event A is equal to 30 by 1000, which is equal to 0.0. Okay, now the second question is being 30 to 50 years age and having 1 or more accident in 1 year. So we will concentrate over 30 to 50 part only of the age group. Okay, so the number of drivers in 30 to 50 and having 1 or more accident. Okay, so having one and more accidents. So number of drivers in 30 to 50, that they are 63 plus 30 plus 11 plus 9, because the question is asking to find one or more accident in 1 year. Yes, so let this particular event be denoted by D. Therefore, the probability of a particular event B is equal to 113 divided by 1000, which is equal to 0.11. Now, the third question is having no accidents in 1 year. Yes, it means that having zero accidents. So we will see as the age group is not provided, so we will just see the no accident year. Okay, so that is 220 plus 252 plus 180, as they have not given the age group. Yes, they are seeing all groups we have to consider. So 220 plus 252 plus 180, which is equal to 652. So let that particular event is denoted by C. Therefore, the probability of event C is equal to 652 divided by 1000, which is equal to 0.6. Okay, now students, we will consider one more example. Two balanced dice are tossed 50 times and the sum of the integers on the dice are noted in the table. All the information is provided in the table. So sum is given 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. And frequencies are given 3, 9, 8, 8, 4, 5, 1, 3, 7, 2, 0. Yes, the respective frequencies are given. Now what we have to find out first is find the probability of the following event. So the first event is sum of integer is more than 9. Yes, so we will see more than 9 on the given table. Now the second is sum of integer is exactly 7. Yes, so we will concentrate where the sum is exactly 7. Now the third is sum of integer is less than 6. So we will concentrate where the sum of integer is less than 6. Now we will come to the solution part. So total frequency is given 50. Yes, because the two balanced dice are tossed 50 times, it means that the total frequency is 50, which we are denoting by small n. So let A be the event that the sum of the integer is more than 9. Yes, and B be the event that sum of the integer is exactly 7, and C be the event that the sum of the integer is less than 6. Okay. Now for an event A. Yes. So what? First event is A, so we have to see sum of integer is more than 9. So more than 9, the frequency is 7 plus 2 plus 0, which is equal to 9. Yes, so for event B, sum is exactly 7, the frequency is 5. Yes, for an event C, where we are considering sum of integer is less than 6, so we will add 3 plus 9 plus 8 plus 8. Yes, now the probability of a particular event A is equal to 9 by 50. Yes, when we solve we will get 0.18. Now the probability of getting an event B is 5 by 50, which is equal to 1 by 10, which is equal to 0.1. And the probability of an event C is 28 by 50, which is equal to 0.56. Hope you have understood the concept of chapter probability. This chapter is important, easy, because the same chapter will come in your 10th standard. I hope you have understood with that chapter. Please like, share and subscribe our YouTube channel. Thank you.